Welcome to the PinPoint III Diagnostic class on Flowmeter Setup and Settings. So in this tutorial, we're going to talk about all the different types of Flowmeter settings that we can program, how those Flowmeter settings change the behavior of your machine, and all of the components that are involved in order to do flow control on a PinPoint III system. So a PinPoint III doesn't control flow in the traditional conventional flow control method. Instead, we use a method where we fuse different sensors together in order to get a faster and more accurate prediction and control of our flow. So the traditional way to control flow is with a sort of turbine-based flow meter. Everybody's familiar with these. They're on their machine. And the way that a turbine flow meter works is you get flow coming through your boom, and your rate controller measures the frequency off of that meter, and then based off of that reading, it increases and decreases the total flow coming through the machine to match the target rate. So we still use a traditional flow meter with our PinPoint III system, but we add in a second piece of information, and that's our electronic pressure transducer. So the flow meter can measure flow by measuring the total volume of liquid coming through there. But with our pressure transducer, we know that we have a fixed tip size, we know what the pressure is, we know what the speed is, and we know what the duty cycle of our nozzles is. So since we have all that information and we know the pressure in the boom from the pressure transducer, we're also able to calculate what the flow rate is based off of the pressure duty cycle speed relationship. So on our machine, we have two different methods of sampling and detecting flow, and by merging these two solutions together, we can get a more accurate and faster flow response. A flow meter is really good at getting the flow over a period of time, but you have to make a change at the pump. That change has to come through the boom. It has to be measured by the flow meter. It has to come out of the boom. It has to be constantly sampled and resampled over time and adjusted to get the flow rate right. So it takes a little bit of time, and we're looking to make really, really quick and accurate rate changes. So the nice thing about using the pressure transducer is the pressure in the boom is instantaneous. We can measure it all the time, and we can measure it very, very rapidly. We can measure it every 20th of a second, every 50th of a second. As often as we want to, we can measure that pressure. And we always know what the nozzle duty cycle is. We always know what the speed is. And so having all of this information means that we can exactly calculate the flow rate coming through that nozzle at any point in time. So the way that a PinPoint III flow control works is when you make a big change or a rapid change, we do a predictive flow calculation. So we see the speed go from 12 to 18 miles an hour. Well, instead of waiting on the flow meter to tell us if the flow is right, we look at the pressure transducer and we say, okay, based off of the boom pressure and the nozzle duty cycle, are we on the target rate? If not, we instantly snap the duty cycle to the correct target rate. And then once we get to the correct target rate, we switch over and we look at the flow meter and say, hey, did we get our predicted flow correct? And then the flow meter reports back to us either we're perfectly on or off, and then we can feather it in until we make some other big change, whether that be rate, speed, pressure, whatever it is. We use two different solutions in order to come up with the answer, and the result of that is extremely rapid and good rate control. And we're going to talk about going into the flow meter settings and each of those and exactly how that's going to make the machine behave in our next segments. Now that we have a little background on how our flow control and flow meter and pressure transducer setup works, we're going to go into our VT screens and we're going to look at all of the settings, and we're going to talk about how each of those impacts the flow control on your machine. In order to do that, we're going to come into the in command into our VT screen. From there, we're going to go into the wrench. We're going to go into flow. And in the flow menu, we're going to go to Flowmeter Setup. Within Flowmeter Setup, we have several fields that we can talk about. Right now, we're going to talk about Meter 1 type. And just for reference, Meter 1 or Flowmeter 1 is always your product flow meter, or the flow meter on the machine that's measuring the dispensed product out of the boom. We also have a Meter 2 in here. That's always going to be a fill flow meter if you have a fill flow meter on the machine. So Meter 1 type, we have a few different settings in here. We're going to look at these top three, which are transparent, correction, and calculation. So first we'll set it into transparent mode. So when we talk about transparent mode and how that behaves, this would be a traditional flow meter style rate control. When you put the system, the Meter 1 type, into transparent mode, the PinPoint III goes and looks at the turbine flow meter, and it uses only the turbine flow meter to figure out what the flow is coming through the boom, and then as you increase or decrease speed or change your flow rate, it uses only the turbine flow meter to figure out what the flow rate is in the boom. So this is just a traditional flow-based controller type control when we set Meter 1 to transparent. When we set Meter 1 to calculation, it now completely ignores the flow meter. It doesn't care what the flow is being reported from the flow meter. It goes to a pressure-based only calculation where it looks at the pressure transducer, the nozzle duty cycle, the speed, and it uses all of these parameters to calculate what the flow would be. So now you're in a operation mode where we strictly calculate the flow based off of the boom pressure, or if you're in the transparent mode we just talked about, we calculate the flow only based off of what's coming through the flow meter. So by selecting calculation or transparent, we can actually impact how it or what it looks at to control the flow. And that's very important because if you have a flow meter fail on a machine, you can always run off of the pressure transducer. If you have a pressure transducer fail on the machine, you can always run off of the flow meter. So that's all good and well, but what we really want is what we talked about in the intro video, and that's to use both of these solutions together. So assuming that we have both sensors in working condition, we're going to want to run in correction mode. So in correction mode, this is where we use that fusing the sensors together, or sensor fusion technology, to merge both the flow from the pressure transducer that's calculated to the flow from the flow meter that's measuring the product coming through the boom. And we bring those two solutions together. So we use the pressure transducer to do a predictive flow calculation for extremely fast rate snapping and on-target acquisition. And then we use the flow meter to feather in that flow once we make that snap. So correction uses sensor fusion technology to get everything very rapid and uses multiple sources to calculate and predict the flow and measure it as well. And transparent and calculation give you two different modes where if you don't want it to do sensor fusion technology for some reason, you can select flow meter. Or if you don't want it to look at the flow meter at all, you can choose a pure calculation mode. So those are the three primary types of control or settings that we have for the Flowmeter setup for your PinPoint III system. Some additional settings we have within the Flowmeter setup environment are Meter 1 minimum. And in this particular case, it's set to 3 gallons per minute. So what this Meter 1 minimum means is that anytime the total flow in the boom is less than 3 gallons per minute, we ignore the flow meter and look strictly at a pressure-based calculation from the pressure transducer. And this is independent of how you have this mode set up here. Because what this Meter 1 minimum says is that every turbine-based flow meter, or flow meter for that matter, has a certain minimal threshold where it can operate. And once we get close to or below even that minimum threshold, the information coming from the flow meter is really not very good. So in that situation, we would not want to be using the flow meter information to calculate the flow if it wasn't accurate at that point in our application. So we simply choose to, at a very low flow that it's not capable of doing a great job at, to throw that data out and used a much more accurate calculated flow based off of the pressure transducer. So we call that the handoff, right? The minimum one, or meter one minimum 3 gallons per minute is when it hands off from its sensor fusion to strictly a calculated flow solution. So that's what meter one minimum does. So again, meter one minimum is tied to the dispensing product flow meter, the one coming out of the boom. Now we have a meter two minimum down here as well. You can see that it is set to 0. And this is very important because meter two is your fill flow meter. And because we don't have a pressure transducer or a tip or a speed even whenever you're using your fill flow meter to put product on the machine, we always want to leave that meter two minimum at 0 because we don't want it to ever start trying to calculate what the flow is. And on this meter two type as well, since it's the fill flow meter, we always want it to be in transparent. So it's only ever looking at the flow meter to figure out how much flow is coming into that tank. So it's very important that your meter two type and your meter two minimum always be set to transparent and 0. So it's always looking at that fill flow meter correctly to put product into the tank. Now, in addition to that, we have a meter one calibration number. So this number is very simple. Everybody knows we go look at the tags on our flow meters. Those flow meters all have calibration numbers on them, and we're going to enter that calibration number here in pulses per 10 gallons. And you need to do that both for your dispensing flow meter, your meter one, and you need to do that for your meter two calibration as well. And all these need to do is match what's on the tag, and our units are pulses per 10 gallon. And the last setting that we have in relation to these flow meters is a specific gravity. Right now, all we're supporting is that we set specific gravity to 1. This has to do with the weight of the product. And since we're using both the pressure transducer and the flow meter on there, we leave that specific gravity to 1. There can be certain situations if you're not using the turbine flow meter where we would want to adjust that. But for most of our solutions today, we're going to leave that specific gravity to 1. The last item we want to discuss in the Flowmeter setup is this meter one error limit. And meter one error limit is, it defaults to 50%, but meter one error limit gives us a really nice diagnostic tool. And the reason we have this in there is because we have a pressure-based calculation where we're calculating the flow rate. And we also have a turbine flow meter that's measuring the flow coming out of the boom. And one of the pieces of information that is really helpful to know is how close is the calculated flow from the pressure transducer to the measured flow from the turbine flow meter. And that is what this Flowmeter 1 or meter 1 error limit helps us understand. So the default is 50%. We can program that down to something like 20% is sometimes a good number to set that to. Now, when we come back in here to our home screen, we're going to see, you can see the Flowmeter error percent right here in this rate control box. Now, from a prior training, I had that set up a little bit different, so I'm going to set that to display rate again. So now this box is going to show our target rate, which I'm going to set to R1 or 10 gallons per acre. You see this Flowmeter error percent right here is at 0% because no flow is coming out of the boom. So right now, both the turbine flow meter and the pressure transducer agree that there is 0% flow, or they're calculating the same thing. So there's no error in what they're calculating. Now, the next thing that we'll do is we'll come in here and we'll put in a self-test speed of 10 miles per hour. And I'm going to run my boom tube profile, which just turns off my solenoid valves, which are attached to this middle boom section. We're running a simulated pressure, so I don't have a real sprayer here with real product coming through it. So I have a simulated pressure and I have no turbine flow meter. So when I turn this on and start spraying, turn the pump on, turn the boom on, we're now simulating a PinPoint spraying live product. So if we come in here right now, we can see this Flowmeter error is negative 100, or the flow meter is counting 0 flow right now. But because I see a pressure in the boom and I know I have nozzles on and duty cycle and a speed and a nozzle size, the pressure transducer is calculating that a flow is coming through the boom, even though the flow meter can't physically measure it right now. So that's where this Flowmeter error comes in. It's telling us, hey, you're off negative 100, or the flow meter is not reporting a flow at all. So this diagnostically can be used to figure out, okay, well, is my flow meter actually working? Now, in a typical spraying environment, we should see that this Flowmeter error is somewhere in the, within 5 to 10% of the calculated flow. There's always going to be a little bit of discrepancy between what we calculate the flow to be and what the flow meter measures the flow to be. So that's why we usually set it out to 20%, so it's not alarming all the time. But if it gets way out of range, it'll give us a warning, and you can see that down here, this fault 123 flow percentage. It's saying, hey, your flow meter is way out of line with your calculated flow from your pressure transducer, so it gives us an error. Now, this error is handy, again, I said, because we can actually see if our flow meter is working. In this case, I can see that if there was actually spray coming out of my boom, that my flow meter isn't working. I need to replace my flow meter. Another practical scenario here is that we have tip size over here. So if you have this number 6 tip selected, but you actually have a number 8 tip on your machine, well, then we're going to be calculating the flow based off of an 06 tip, but the flow meter is going to be measuring the flow coming out of the machine by the actual 08 tip that's coming on it. So it's going to be off by about 18 or 20% already. So if you accidentally select the wrong tip size, this Flowmeter error can give you a warning to say, hey, your flow is way off. Maybe we need to get the right tip size selected. Another example where we found this Flowmeter error to be very handy is many booms have recirculation on them now. And we've actually seen where some recirculation valves have not closed all the way, that mechanically there was something blocking them and they were partially closing, which allowed flow not only to come out of the boom, but to return back to the tank. So the actual applied product was low, but the flow meter was counting correctly because the part that wasn't coming out of the boom was still coming through the flow meter. It was just returning to the tank. So by seeing that, hey, the Flowmeter error is off here, you're off of what we're calculating it should be, we can use this information to figure out what's going on the machine and get our flow in both our turbine flow meter and our calculated flow correct, so that we come up with the correct amount of product coming out of the boom.